Hi, and welcome to the next in our series of Women Tech Makers, coming to you from Campus London for Google Developers Live. I'm Emma Jackson. I look after Google's education programs on privacy.
And I'm Mandy Waite. I'm a developer advocate on the Google Cloud Platform. We're absolutely thrilled today to have with us Dame Wendy Hall. Wendy Hall is a Professor of Computer Science at University of Southampton in the UK. She is also the Dean of the Faculty of Physical Sciences and Engineering. She has published over 400 papers, and she is frequently invited to speak at high-profile conferences and events. Together with Sir Tim Berners-Lee and Nigel Shadbolt, she co-founded the Web Science Research Initiative, and she's a director of the Web Science Trust. Not only is she a Dame Commander of the British Empire, but she's also, I'm very jealous here, a Fellow of the Royal Society, and she's also a former president of the Association of Computing Machinery, the first person outside of North America ever to hold that position. Welcome, Wendy. Thank you for coming.
Oh, it's a pleasure to be here. Nice to be with you.
So we mentioned in your bio that you co-founded the world's first interdisciplinary body to study the structure and sociology of the web. Can you tell us a bit more about what you're doing with that organisation?
The Web Science Trust.
Web Science Trust.
Well, when we were thinking about this back in 2005, 2006, Tim, Nigel and I and Danny Weitzner, who worked with, is a lawyer who worked with Tim at MIT on policy and has since been in the White House. We were thinking about how the web evolved, and we were actually thinking about why the semantic web wasn't taking off, why people weren't rushing to develop links for data as well as documents. And in looking back at how the web had evolved, we realised we just, despite the fact one of us was the inventor of the web, we so little understood how it had happened. And we also began to realise that that this wasn't just about the technology. It was about what people did with the technology, and in fact what society did with the technology over time, and how the circle of the technology goes out, people do things with it, and then the technology changes. So there's a feedback loop, and it's very different to the way we were used to designing computer systems. And so we thought, well, actually, it's so important that we understand this. It is a whole new discipline, and it's very interdisciplinary because we need social scientists and technologists and lawyers and economists and business studies and maths and psychology and so many different subjects that impinge on this. We decided to give it a name. We called it Web Science, for good or bad. Many people think we're saying websites, but it's Web Science. And there's two things we don't like about that name. One is web and the other's science. Because it makes it feel more technical than it's meant to be. But there were people studying this, but it didn't have a name, it didn't have any cohesion or coordination. So the Web Science Research Initiative was an agreement between Southampton and MIT to, those two universities backed us in developing this, and then over the next 3 years we evolved it into the Web Science Trust, which is a charitable trust based in the UK, but it's a global reach, and its mission is to promote awareness of web science research and web science education around the world. And now we have a network of 15 laboratories around the world who coordinate their efforts in web science, do collaborative research and share education experiences. And many people now run web science programs, and we have an annual conference next week. It's in Paris. And we run workshops and thought leadership events, and just generally raise the awareness of what we think is a really important paradigm shift in the way systems are developed, and help us think about how this ecosystem might evolve in the future.
Okay, so in terms of web science, then you kind of gone over what the fundamentals of it are, but it's kind of like a science such as physics or chemistry, so you're applying that to the web, and the web is constantly evolving in front of us. Things are changing, we don't quite understand it. It's almost organic in the way that it grows and changes, in the way hotspots kind of appear and things change. So you mentioned web laboratories. What do you do in a web laboratory?
This is absolutely crucial to what's happening, because it is a we've built the system. It's built by human beings, but it isn't a natural system, so you can't apply the laws of biology to it. So you can say it evolves, but it doesn't evolve in the same way that plants evolve, or does it? I mean, what are the laws of evolution of the web? And it's also, there's an engineering piece to it, because engineers design the protocols that make things happen, and then some of them succeed, some of them fail, lots of them fail. People try and build applications and companies, some succeed, lots of them fail. And in order to study this, as you say, it's evolving all the time, and it's getting bigger all the time. It's huge. You can't take a snapshot and say you understand it, and you can't just study it in the UK or in China or in the US or in one university so what you've got to do, we think, longitudinal studies, and you've got to be capturing what's happening day in and day out. We talk about building web observatories or web science observatories to monitor the trends, what's emerging, and it's not just about what's happening on the web, but what's the technology development piece and what are the policy pieces. So what when a government changes a law or regulation, changes its policy about something, what impact does that have? And you have to follow that over a period of time. So we've got people observing and doing experiments with the data that's being gathered about what's going on the web, but we're actually with our labs and with companies that are working with us, developing this concept of web observatories. And I liken it to in order to understand climate science, you have to have people around the world taking the temperature day in, day out, all the time, to gather how much has the ice melted. They've got to be doing that day in, day out. We have to be monitoring the web 24/7, and people are doing that, but they're doing it and storing the data on their systems, but in silos, not shared.
You mentioned
we want to share that. No, we want to develop protocols and guidelines so that we can share the data that's being collected and the tools that's being developed to analyse that data, both in research, university research laboratories, and by companies. Share the tools as much as possible to help us build a bigger and better picture of what's going on and how things develop and emerge over time.
You mentioned the regional aspects of it, that you have to do it not just in the UK, not just in China, but everywhere. And the cultural diversity, I've used the web in Japan and China, and it's very much significantly different there than it is here. Is it really possible to do that kind of study equally? Is it possible to say, it's more like a sociological study where you have the cultural differences between people and you have to understand how they relate to each other. But obviously the way they use the web is different from the way we use the web. How do you balance that? How do you get that right?
Well, again, I think you have to gather the data and the evidence. Right. Otherwise, you're hypothesising without those facts and evidence. And we have a PhD program at Southampton, and we've taken our students to other labs around the world, to China and Korea and the States and other labs in Europe, to share experiences. And that is so powerful, to get them to think about how Twitter is used, or even now in China they have their Twitter, Weibo, and getting the students to compare what they tweet about and what are the big stories is very insightful about it. But there's a huge social piece here, social science piece, about understanding how society works, and the coming together of the social and the technical is quite difficult to manage, but that's the exciting challenge of it. And I just love sharing the experiences between the different cultures. But we want the evidence for that. We want to collect the data for the students to analyse.
It's a fascinating area. I was wondering if you think maybe, because I know you've done a lot of work to try and encourage more girls to get in, women to get into sort of this area. So do you think maybe web science is something that would encourage more diversity?
Well, it does. And after 30 years in the business of computer science, it's wonderful to walk into a classroom and have 50% of the audience women. websites naturally attracts women because it doesn't require people to have to be technically minded in order to be involved in the work and the study. You still need the programmers in there to build the tools that you're going to use to analyse the data and have those technical insights, and it's that mix that is so exciting. And our students at Southampton, our PhD students, they come from every different type of discipline onto the Web Science PhD programme, and they have to have at least two PhD supervisors, and at least one of those must be a non-computer scientist. And actually several of the students on the programme have two supervisors, neither of whom are computer scientists. It is not just about the technology. The insights are amazing that we get from that, and it's a natural that this is a diverse group of people that want to do it. We're just launching in Southampton an undergraduate programme starting in October, and we've got two pathways at the moment. These students will they'll get a BSc in Web Science, but at the moment they can come in with either a computer science type background, so technical type background, or a social science type background, and have training in their core disciplines and training in web science type fundamentals, and then can weave their way to a web science degree coming in from different backgrounds. And next year we'll add a management pathway, and then there's going to be a humanities pathway and a legal part. Oh, it's so exciting. It's one of the most exciting things I've ever done, developing this undergraduate programme.
So it's interesting you talk about the courses that have been offered by Southampton University. I assume are MIT doing something similar as well?
Well, no, they I mean, obviously they're part because this is one of the places it started. They're part of the Web Science Laboratory Network.
Okay.
They are developing new types of courses, but it has a very they're more on the iSchool slant of things. So it's that we work very well together. So we our students talk to each other.
So basically, I had this question about talking about the courses that are being offered by Southampton University. So you have the undergraduate course, and you have also this doctoral training lab that offers PhD and master's courses. The question would have been just simply what would be the role of the web scientist that these courses would produce. But my question also, I want to expand it a bit now, because I know when I look at physics, I mean, physicists are moving towards a certain goal. They're trying to discover the key to the universe and to understand how the universe evolves.
Well, we're trying to discover the key to the digital universe.
Exactly. So what is the outcome of web science?
Well, I think, what's the outcome of web science? We are trying to understand the digital universe.
Right.
And our thesis is it is a new type of discipline. I genuinely believe that this is as fundamental, a bigger paradigm shift as the paradigm shift that happened in the 50s when we started developing computer science as a subject, based around the concept of Turing machines. And now this is a new discipline. What's happened with the internet and the web has created a whole new way of building and designing systems. And in fact, Tim gave it a name when he wrote his book Weaving the Web. He talked about the type of systems, applications that we would be able to develop on the web. He talked about them as being social machines. These are systems where the machines do the administration and the people do the creativity. And that's what we're seeing. You see, Google is a social machine. Amazon is a social machine. Twitter's a social machine. The web itself is a social machine. It's where you've got computers and people working collectively together using the network effect to create and things that didn't exist before, that couldn't exist before, like Wikipedia. It is an example of something that's been created in that way, and understanding that creation process is we think something really different to what's happened before. So I haven't really answered your question. I've opened it up in a different sort of way, but what a web. So I think that the web science itself is trying to understand the laws, what can you say are the. If you think about, we talked about different cultures. The web in the UK or the US compared to the web in China. There are some things that are you need search engines. Whatever you do, you need a search engine, and the social networks evolve. There's no stopping. But what people use those for are very different in the different cultures. And I think businesses need to understand, especially in the digital world where you're running a global business, and you might think, well, if I'm going to, sell this product, it'll be the same in the US as it will in China, and it won't. But anyway, putting all these pieces together. So web science is the study of this phenomenon and trying to see if there are rules and theories and that you can say are givens. But then web scientists are the sort of people that are going to help businesses and governments understand how to work with this type of evolution of this type of system and think about what's going to happen in the future. So it won't be a black and white science. You won't be able to say, yes, if you do this, then that will definitely happen. But it'll be, if you do this, then that might happen. And if you don't do this, then this will never happen. And particularly we want to give evidence for policymakers and big companies to think about what their future might be as these trends emerge and what the good and bad things to do.
Is it likely, sorry to keep asking questions, but
no, please do.
Is it likely that we're going to expand web science to other universities throughout the country? I mean, rapidly. I mean, is it going to be limited to Southampton for some time, or are we going to see this kind of emerging everywhere? Not everybody calls it web science. There's lots happening in the States, but they don't always call it web science. And there are some people call it social computation. I just think that more and more people are copying, mirroring what we're doing. And as I say, we've got this network of 14 laboratories around the world who are all, call themselves web science laboratories, and they have PhD programs and beginning to develop undergraduate programs. And there are lots of master's programs called web science. The worrying thing is I looked at one, I won't name the university, it was somewhere in the States, not one of the big, but and it was advertising a master's in web science, and when I looked at it, it was a computer science master's with one web technology module, and I thought, wow, that's not web science, but hey, what can you do? The cat's out of the bag, and people will make of it what they will, but I know what I mean by it.
Right. So you talked about these sort of web scientists, I guess, that monitor trends in technology or the web. And
they're sort of the information scientists of the future, Anyway,
well, I was wondering, one of the trends at the moment is this advancement in technology to help education in some ways. So things like these massive open online courses, the MOOCs as they are. So, being in education yourself, what do you think about these new advancements and how they might change?
Well, you see, they're not new really. I cut my teeth on the use of computers in education, and I've been, up until now, we've talked a lot about how computers were going to completely revolutionise education, and they have changed, for example, everywhere you go now, there's classrooms, universities are full of computers, students use computers, they write their essays on computers, they hand them in digitally, that they talk to their tutors by email. All that has fundamentally changed, but actually, if you want a degree, generally speaking, you go to a campus university and study for a degree. That has not changed. The MOOCs are a buzzy thing, this idea that you can teach a course using video and self-assessment material online and have hundreds of thousands of people look at it and then get a qualification, or get certified for that course, and then build up to a degree. And if this is really shown to work, then that will radically change how we do education, both in universities and schools. But there's a big sociological piece to this, because do young teenagers need to learn in a cohort? Do they need that psychological encouragement of their peers and their tutors, in a physical environment, in order to learn? You can't send somebody to a library. You can't I don't think you can send a teenager to a library and say learn. They can go read a book where they can't learn. A mature student, very different kettle of fish. I think there's many master's courses which are delivered online successfully, because mature students want to learn. They've already learnt how to learn. Either they've done a degree before, or they've worked through a work, by learning while they work, and they're paying for something that they want to do, and they'll, they already have families and stuff. But I think it's very, the jury is out on whether that's how 18-year-olds can do it. Right. But I do think it potentially does say you no longer need a campus university, or dare I say it, a physical bricks and mortar school. But I think the universities have really got to look at what their future is if this technology does take hold. It's very interesting, and it is definitely. You could say this is a web science thing. It's but it's a education thing as well, and I find the whole thing fascinating. We're actually, just to be incestuous, we're doing a MOOC about web science at Southampton, which should be online in the autumn. So we'll see how that goes.
Excellent. So, back before the advent of the World Wide Web, you and a team from the University of Southampton invented Microcosm, which was one of the very first hypermedia servers. Probably we can expand on what hypermedia servers are, but it's very similar to what we have today in the web. And at the time, you've spoken about this in other lectures and such like, and other speeches you've done, there was a BBC documentary called Hyperland that starred Douglas Adams, and was also written by him, and also starred the fourth Doctor Who, Tom Baker. He played a software agent, and I think Douglas Adams played a kind of bored couch potato. And Tom Baker introduced him to the notion of hypermedia. And
he introduced him to the idea of finding anything he wanted when he wanted it.
Exactly, yeah. So a microcosm really kind of was born out of that, or at least you said. So I'm just really interested to understand the reality of it. But you've said before that it really inspired you to go out and build microcosms. How much is that true?
It's absolutely true. I was really getting into the idea of using computers in education, this concept of multimedia, which in those days was analog video, audio on tape, text from files, and somehow we got all that together onto one computer screen and linked it all up, and it was very primitive compared to what we have today, but you could see the potential. And I met the gurus of hypertext. I met Ted Nelson and Doug Engelbart, and there was the first hypertext conference, ACM hypertext conference in 1987, and there was a very sort of timely there was a time when this was all emerging. At the same time in CERN, Tim was inventing the web, right? And that Hyperland video was released in 1987. Yeah. That was the year that Apple released HyperCard, and I watched that not the video, I watched the TV program, and I thought, I want to build a system like that. I want to build a system with a software agent that helps me find the information I want when I want it, and I'm convinced that hypertext, hypermedia is crucial to this. And so we set about developing this system. Microcosm wasn't the first. There were been hypertext systems for a couple of decades before that, but it was what we did with Microcosm was we stored the links separately from the documents. They were first class entities, and they had meaning. They weren't just point to point links. The information encoded in them said why that link was created. So it was a precursor to the semantic web, actually. But what we got wrong was what Tim taught me was this stuff works if either nobody will use it or everybody will use it, and so it's got to work over the network. It's got to be free, open and free, and the protocols have got to be, the standards have got to be open. Microcosm was proprietary. And so those were the things that Tim got right with the web. Give it away, open protocols on the network, and so we got a lot of that wrong with Microcosm. But we did get the idea of having intelligent linking, and that's really what's exciting for me about what's happening now. Is that's the semantic web, and that's what we're seeing emerge today. Right. So it's about 20 years since, or more, 20 22, 23 years since we first did microcosm, and it's exciting to see those ideas emerging in today's web.
Oh, wow.
Oh, definitely, yeah.
Yeah, that's very cool. So what, in today's web, what excites you in technology at the moment?
Well, I think we are seeing the semantic web emerge, the web of data, Web 3.0, the idea that we're not just linking documents, we're linking data, and we're linking data in such a way that there's that meaning about why that link is there. That means you've got to, of course, you have to tag that, you've got to explain you've got to say what the data's about, right? You have to have ontologies, but you can do it in a very simple way, and we are really beginning to see that emerge. With Google's got its knowledge tree, and that's, it's all that's really exciting. The other exciting thing, of course, it's all happening in the mobile world, and the 80% of the world that isn't on the internet is getting on the internet through the mobile technology. So we're seeing another whole scale up of this amazing ecosystem that we've developed, and I think that's it's changed the world already, but we haven't seen anything yet.
I did have a sweepstake running about how many times you would use the word ontology.
Once. I tried not to.
Because web scientists generally are very averse to using the word ontology. Why is that?
Well, I think because it sort of overcomplicates the issue.
Yeah, it does.
Yeah, and you don't have to develop the perfect ontology in order to share linking information, share information. So
I think semantic web probably explains it a bit better. I think even then semantic web might still be a little bit too complicated for people to understand. So is there a better way we can actually frame it?
Well, I talk about the intelligent web really more, and so nowadays if you look for something, you use a search engine like Google, you get a list of links back. In the future we'll look for something and we'll get the information that we wanted to answer the question that we had.
It'll be contextual.
Yeah.
Okay. I have an idea. You could call websites webology.
Actually, it was one of the things we went through, but we decided that didn't sound serious enough.
Ology is good.
We did. That was on a. Tim wanted to call it philosophical engineering.
Oh no!
Oh wow!
That would be
Yeah. But we decided people wouldn't understand what that was, but that's what it actually is.
Well, thank you so much, Dame.
But is the time up?
Well, we can talk about more. What other questions do we have? How many? We got 2 minutes.
I think
we have 2 minutes. Okay. I guess so. Yes.
Yeah.
Thank you for coming today. It's been wonderful having you here and learning about web science, because web science is pretty new to me anyway. So it's been a real experience and a joy actually watching you talk about it. And,
fantastic to have the opportunity to talk about it. I should add that as I said to you before, it doesn't mean I don't want women to do computer science. I think it's really important that we get women into computer science, and it's such an uphill battle for us. We need to look to the countries like the Far East and India, where women aspire to be computer scientists. We don't have that culture here, and we somehow need to get that buzz. And I'm hopeful, but I don't have that problem with web science, because this is something that women naturally want to study. So that's.
Well, the aim of Women Techmakers is to kind of plug away at this and to try to present role models to young women and
such as
women of all
yourself.
ages. Such as yourself, yeah. So hopefully we're doing that, and well, thank you for coming along today. It's been really wonderful to talk to you. And
my pleasure.
Thanks to Emma. Thanks to our producer Ian, and this was Women Techmakers from Campus London. We'll hopefully have another event for you soon. In the meantime, goodbye.
Bye.